Okay, in this video, I am going to demonstrate how to factor trinomials of a specific type. So recognize that trinomial, that implies three. So these are polynomials that have three terms. And if you look at these couple of examples, you can clearly see that there's 1, 2, 3 terms. All the examples will be set up that way. But we're actually going to focus on a specific type. And these are actually called quadratics. Because they're of the form ax squared plus bx plus c. So those become our three terms. A, b, and c, those are just numbers. They're coefficients. They might be positive, they might be negative, they could be fractions, but they're just numbers. And then the variable term is the x. Now, you don't have to use an x. It's just kind of the most common. But for example, I have an example down here where I've used p. So you can really use whatever letter you want. So don't let that throw you. The key is that these are all going to be trinomials. And the factoring technique we're going to use is called the AC method with grouping. And so these are all going to be quadratics. Now, there are multiple ways to factor trinomials. The AC method with grouping is just one approach. I like this approach because I think when students are first beginning their factoring journeys, it spells it out cleanly and pretty efficiently. It's a process. And as with any process, the more you practice it, the sooner you're going to learn it. And so once we go through these couple of samples, if you feel like you're still not quite getting it, then I'd encourage you to practice some more, and I'll actually point you to a resource online where there's some additional practice problems. Again, so we're going to do trinomials. They're going to be of the type ax squared plus bx plus c, and we are going to use the AC method with grouping. If you are an experienced factorer, you may do something called trial and error, which basically means you're kind of doing AC method in your head. If you have learned an alternate method for factoring trinomials that you like, then keep doing it. By no means do you have to stick with this method. If you have something that's working for you and you are getting the correct answer every time, then go ahead and continue with that. But if you are new to factoring or have struggled with it, this is a good method to get you headed in the right direction. Okay, so these first couple I've kind of preliminarily set up what we need to do. So the first thing is when you have your trinomial, again, we are not going to violate our rules of factoring, which I'll remind you what those are really quick. We need to make sure that our polynomial is in descending order. We are going to pull out a GCF if we can, and then when we say which type, these are all going to be trinomials, and we're going to proceed with that process. So don't forget about step 1 and step 2, please. These first two that I have set up, they are both in descending order already, and we cannot pull out a GCF, but you definitely want to look at that before we get started. So once we have confirmed descending order in GCF, this is our resulting trinomial, and if we look at this format, these coefficients are the A, the B, and the C, and those become important to recognize because this name, the AC method with grouping, the AC, that comes from looking at the A and the C, and so there's meaning, important meaning behind that name. And so when you first start out doing your factorization, you need to take the A and the C, and you're actually going to multiply those together to get a number. And the signs matter. You know, these were both positive, so they're positive. If this had been a negative and a positive, then I would have had a negative result here. So the signs matter. In this case, positive times positive, I have a positive 126. And then we need to go grab that B, and we're going to place it right there. What we're going to do is we are going to come up with a list of factors of two numbers that multiply to get the positive 126, but when we add those two numbers together, we're looking for the combination that adds to give us the B, and this will make more sense as we do some examples. So remember the goal, if you watched the 4-term polynomial factoring video, is the AC method with grouping. It teaches us how to take the trinomial and how to break it into a 4-term polynomial. The first term we're going to leave the same. The last term we're going to leave the same. And this middle term, we actually break it up into two pieces, and that is why we are going through this process over here. It allows us to figure out how to break it up. So let's get started. Sometimes when you have the a times the c, you might just see right away what are the two numbers that multiply together that result in the b if you add them. But sometimes you don't. Like, I can't think off the top of my head right now of two numbers that if I multiplied them together I get 126, but if I added them together I get 23. And so that's where this process will kind of flush those numbers out for you if they exist. I have an example later where there actually don't exist. There aren't any. And if that's the case, then we would call the polynomial, we would say that it's prime, that it doesn't factor. Okay, so let's get started with these. So first of all, a great process to follow if you cannot see what those numbers are is to just start with a 1 and say, well, 1 times 126. If I multiply those two numbers together, that would equal 126, so that's a possibility. Also recognize that it also could be -1 times -126, because a negative times a negative also results in a positive. Now what you want to do is you then want to add these together to see what you get. Well, 1 plus 126, that's 127. That is not 23, so this is not the set of numbers we're looking for. Likewise, if you combine these, you're going to get -127, which is also not correct. I do want to point out, when a times c is positive, that means that your factors are going to be a positive times a positive, or a negative times a negative. That's the only way you'll be able to multiply things to get a positive number. So the sign on the b, if you're paying attention, you can eliminate some options right away. The only way you're going to get a positive b when a and c are the same sign is they both would have to be positive, because if I ever take two negative numbers and add them together, I'm going to get a negative. So instead of having to list the positive and the negative cases as I go down, if I think about it, I really don't need to look at the negatives on this one. So let's keep going. So a great process is to say, well, 1 times 126, and then we're going to count up by 1 and say, well, does 2 go into that number? And it does. That's even, which means 2 will also be a factor. If you're not sure what 2 is partnered up with, you could take 126 and divide it by 2 in your calculator to find out what that other number is. If you do that, we find out that 2 times 63, those two numbers multiplied together are also 126. Again, if I add those together, those add up to be a positive 65, and that is not what I'm looking for. So I keep going. So let's go to number 3. Does 3 divide into 126? And it sure does. Again, if you're not sure, take 126, divide it by 3 in your calculator, and we will get 42. Again, those don't add up to the right thing, so those add up to 45. And you don't have to necessarily write down what they add up to. If you do that in your head and you can tell that it's not right, then you've considered that pair and you can move on. So this isn't right. But look, I'm getting a little bit closer. Initially, these first two, that was a pretty big number, but as I am increasing the left factor and decreasing the right, I'm getting a little bit closer. So we're going to keep going and see if we can find this set of numbers. So let's try 4. Again, we're kind of just counting up by 1 each time. So if you try to divide 4 into 126, it doesn't work. You actually get a decimal. So 4 is not a factor of 126, so we skip it. And then likewise, let's go to 5. 5 also does not divide into 126, so we skip it. If I go to 6, 6 will divide into 126. Again, you can use your calculator if you need to, and it happens to be 6 times 21. Well, if I add those together, I get 27. Still not the correct pair, but gosh, I'm getting close. So let's keep going. 7 does not divide into 126, so I'll skip it. 8 is the same situation, skip it. 9, if you try to divide 9 in, you find that that works. 9 divides into 126 actually 14 times. And if you add these together, oh my goodness, we get 23. So this is it. This is the two numbers that when you multiply them together, you get positive 126, and when you add them together, you get 23, which is my B. So this is my guy. If this hadn't been what I was looking for, I would have kept going. I would have tried 10. That wouldn't have divided. I would have tried 11 and 12. And you know that you're done listing factor pairs if you're doing this process of counting up by 1 each time. If this list on the left catches up to this list on the right, then you know that you've listed all the factor pairs and you didn't miss any. But thankfully, we found the pair that we were looking for. So I call these my two magic numbers. So these are the only two numbers that will allow me to factor this polynomial using the AC method with grouping. And what we do is, if you remember what I mentioned before, we take the first term and we just copy it exactly as it is. And then we take the second term and we're going to copy that. Now we're going to use these two numbers to break this middle term into two pieces, okay? Well, these are x's, so I can't forget the fact that they are x terms. So I'm going to break this into a 9 and a 14, both with an x. So I have a 9x and I have a 14x. And this was a positive 21, so let me get that included there. And then when I break this apart into two pieces, it's a positive 9 and it's a positive 14. And so if you think about it, in earlier math courses, if you've been given something like this and asked to combine like terms, because these were both x's, we would have combined them together and this would have been the simplest way to write that polynomial. But when we're trying to factor using this method, we actually want to break them back apart. And there are a lot of ways you could add two numbers to get 23. It could be 1 with 22, 2 with 21, 3 with 20, etc. But there's only one way to break it apart that will allow us to factor, and this process flushes those two numbers out if they exist. Okay, so now this turns into a grouping problem. And if you recall from the grouping video, the 4-term polynomial factoring video, you pair the first two together and the second two together, and we treat them as two separate grouping problems. And so I'm going to move through this part pretty quickly. If this is something you're not following, you're going to want to go watch the video on factoring 4-term polynomials. So as I look at this first set, I can pull a 3 out of these two numbers and an x. So let me pull out that 3x, and that's going to leave behind a 2x plus 3. If you're not sure if that's correct, again, you could distribute this through and confirm that you get that expression above. This second one, I can pull out a GCF as well. Remember, if you can't pull out a GCF, you have to pull out something. So if nothing is apparent, you're going to pull out a +1 or a -1 if this is negative. But I can pull out a 7 here. So I'm going to pull out that +7. And then what's left behind when I do that, I will leave a 2x behind this first piece, plus sign, and a 3. And remember, when you factor by grouping, those two expressions in parentheses, they better match. If they do not match, you have done something wrong. And the fact that we found these two magic numbers as a part of this process means it will group. 100% guaranteed it will group. So if this doesn't happen, you have made a mistake in here somewhere and you need to go back and find it. Now, let's finish this problem and then I'll address a common question that we receive a lot. So when you're grouping, remember, that's going to allow you to take a 4-term polynomial and write it as the product of two binomials. And what goes in those two places? This matching expression, we're going to drop into this first box. So 2x plus 3. And then what I call like my leftovers or my GCFs, those two pieces we pulled out, those are going to get dumped in to this second set of parentheses. So I have a 3x and then a +7. And so this ends up becoming the factorization for this polynomial. So here's a common question I get. when you find these two numbers, does it matter which order you put them in? And the answer is no. I put the 9 and then the 14. It does matter that they're both positive, like don't mess your signs up. But what if I had put the 14 here and the 9 here? Well, what happens is this will still group. And notice that your final answer has a binomial times a binomial. When you put the 9 and the 14 in this orientation, it caused the 2x plus 3 to be the term that duplicated, and these were your leftovers. If we had flipped those and put them in the alternate order, what would have happened would have been this term, the 3x plus 7, would have been the one that had been duplicated, and these two would have been the GCFs. So just not something you need to worry about necessarily. It's a common question that we get in the Learning Center is, how do I know which order to put them in? And at the end of the day, it does not matter as long as you get them both put in as by breaking this term apart and get the signs correct, you will get to the same place, the same answer. So this will be my answer for the factorization of this trinomial. Okay, so let's do the second one. I wanted to call out that this trinomial, again, it's in descending order. There's no GCF. It's pretty obvious what the b is. That's -8, and the c. But I don't see a coefficient here. When you don't see a coefficient there, it's because it's a 1. And so if it helps you to put it in, go ahead. So here, a times c, that's going to be 1 times 12. So it's, again, this one happens to be positive. Again, it's a positive 12, and my b happens to be -8. And so, again, I'm looking for two numbers that multiply to get a positive 12 and that add together to get a -8. So if you want to start moving through your list, we can do that. Some of you, if you're got good number sense and you're good with multiplication, you might see the answer already. But if not, we're going to go through this process. So is it, 1 times 12? And notice that 1 times 12, if you add those together, you get a positive 13. That is not what I'm looking for. But remember, when you have a positive a times c, it could have been a -1 times a -12. And that would have added to be -13. And this is kind of important to note because the b is negative, which means when your AC is positive and your b is negative, your numbers are going to both be negative. That's the only way you can add two numbers together to get a negative. And so kind of the opposite of what we had going up here, because the AC was positive and the b was positive, we knew it was going to be the positive cases. So likewise here, it's going to have to be the negative cases. If you don't see that, don't worry about it. You can always just list the positive and the negative case each time, and eventually you'll figure out what the right pairing is if it exists. Okay, so it's not 1, so how about 2? So is it 2 times 6 or -2 times -6? If you add these, 2 plus 6, that's 8, and you think, oh my gosh, that is so close. It's positive though, but I need negative, and so you quickly realize, oh my gosh, it's this one down here. It's -2 minus 6, so that's a -8. And this becomes the number I'm looking for. Some individuals will just list all the factor pairs, then they go back and start to see which one's right. I kind of take a peek at each step, because why bother to go list the rest of the pairs if you found it? And again, some of you might have realized it was these two numbers right in the beginning without even having to go through this process. And if you have the number sense and the multiplication ability to do that, then awesome. You found them quicker, you found them more efficiently. All that matters is that you find them. And then, so remember, the AC method with grouping says we're going to use these two numbers to take this middle term and break it apart. And I want to show you something interesting that happens on this problem. So remember, this first term, we're going to leave it the same. The second term, we're going to leave it the same, the plus 12. And we are going to use these two numbers to break this apart. So I have a -2p and a -6p. So use my two numbers. There we go. So let me just kind of point that in so you can follow. Okay, now this turned it into a forward term, which means I'm going to group. So I'm going to group this, I'm going to group this. If I look at this first set, I can pull a p out. as a greatest common factor. So I'm going to pull that p out and then write down what's left behind, which is p minus 2. Now here, it looks like I can take out a 6. And in fact, because this is negative, I need to pull out a negative 6. And then if I write what's left behind, if I divide this by negative 6, I'm left with a positive p. If I divide 12 by negative 6, I get negative 2. So just be really careful about that. Whenever you pull out a negative GCF, just be cautious with your signs that you do that correctly. Now, I found 2 numbers that worked, which means this better group, and it did. If this didn't match, I'd go back up and figure out what I did that was wrong. And so because these match, I am going to pull them into one set of parentheses, so that p minus 2 will be written here, and then those leftovers, those GCFs, they're going to get mapped down into the second set of parentheses. So this ends up being my factorization. And one thing I didn't mention above is if you're really not sure if it's right, you can always use this process called foiling, first, outside, inside, last, to multiply this back together basically and confirm that you end up with the original answer. And that is kind of one of the beautiful things about factoring is once you believe you've come up with the proper answer for a factoring problem, you can always multiply your answers back together. And if you did it correctly, you should get the problem you started with. If you don't, and you are sure that you are foiling properly, then something's wrong. You need to go back and check to find a mistake. What I want to point out is this. Look at this case. These were the 2 numbers we came up with, a negative 2 and a negative 6. And I want you to look at what are the numbers that ended up showing up in our answer. Do you see how we had p's? So I know I'm going to have a p here, but look at that. There's that negative 2 and there's that negative 6. And so this poses an interesting scenario. And this actually always happens. Anytime your A is a 1, this dynamic happens. As soon as you find those 2 numbers that work, you actually don't have to go through this entire grouping process. You can actually jump straight to the answer. Whatever your variable is, in this case it's a p, we're going to put a p and a p here, and then you can take those 2 numbers and actually just map them in. It's called the AC shortcut, and it only works that way if A happens to be a 1. So if you don't notice that A is a 1, don't worry about it. Just go through the entire process. You will get the right answer. But when you have more experience factoring, obviously you want to look for shortcuts when they apply, save yourself some time. And so if you notice that A is a 1, you actually are done right here. You just take these 2 numbers and map them in. Now notice this was not the case in the problem above. My 2 numbers were a 9 and a 14. I don't see any 9s and 14s down here, and it's because A was not a 1, which means you have to go through this full grouping process to get the factorization complete. So again, this is called the AC method with grouping. This is also AC method with grouping the way I've written it, but if I had skipped this entire part and had gone straight from here to here because of this and realizing that A was a 1, that's called the AC shortcut. It's a great little time saver if you happen to notice it. But be cautious. Some students get so used to using this AC shortcut because they do a lot of problems where A is a 1, and then they come back to a problem where A isn't a 1, and they forget. And then they take these numbers and they map them into an answer, and that is very, very wrong. So don't get sucked into that trap. Okay. Another example I want to show is what do you do if you can't find the numbers? And so here I've got t's, which is fine. It's just a different letter to use as a variable. Descending order, there's no GCF. So A times C, that's 18, and my B is negative 5. So if we are looking for 2 numbers that multiply to get 18, I'm going to go ahead and just list them all out because there aren't that many. It could be a 1 times a positive 18, or negative 1 times negative 18. How about a positive 2 times a positive 9, or a negative 2 times a negative 9. And then keep counting. I get a 3 times 6, or negative 3 times negative 6. 4 doesn't go in there, neither does 5, and then I've caught myself. I've caught up to the 6. So this is the entire listing of all the possible factor pairs of two numbers that multiply together to get a positive 18. If we look at what each of these add up to individually, none of these result in negative 5. If we want to finish the exercise, that's 19. That's negative 19. And again, I'm just adding these together. That's 11, negative 11. That is 9, and that is negative 9. So none of these combine to get the negative 5. And if you find yourself in that situation, you may want to go back and double check and just make sure you haven't missed anything. But again, if you follow this process of starting with 1 times the number and then go up to 2 and 3, and if you just index by 1 each time, you won't have missed a factor pair. So you can convince yourself that there is not a set of magic numbers, which means this trinomial does not factor, and we would call it prime. And move on. Okay, so this next example, I want to call out another watch out. We get so used to doing factoring problems, and we see the trinomial and we just want to get started, and so we go, okay, here's A times C, and here's B, and A times C, that's negative 48. Let me write that down. And then my B is negative 2. And then we go off to the races and we start trying to find two magic numbers that multiply here and add to get negative 2. And if you go through that process, you will indeed find them, and then you will go through the full AC method with grouping because A wasn't a 1. Well, if you just went and did that, you just violated the early rules of factoring, right? Which says descending order and GCF. So don't get so used to jumping straight into, oh, this is a trinomial. You need to do those first. And if you look at this, you'd realize that I can pull out a 2. Like there is a 2 that is common to all of these. So let me factor out that 2 and rewrite this as w squared minus w minus 12. So this is actually the trinomial I'm going to go factor. Well, why did that benefit me? This 2 now as a GCF is going to be just out here in front. And so I'm going to go ahead and write that. Now what I realized, this problem, if I do the AC method, A is now a 1, which means I can do this the shortcut way. And so let's rewrite what A, B, and C really are. So for this new one, A times C, that's 1 times negative 12. That's a negative 12. And the B is actually a negative 1. So now as I try to look for two numbers that multiply to get negative 12 and add to get negative 1, and if I go through that process of listing the factors, what I will realize is that as soon as I get to the pair that is 3 times negative 4, because this A times C is negative. When your A times C is a negative number, that means one of the factors is positive and one is negative. So I have a positive 3 with a negative 4, or I also could think of negative 3 times positive 4. But when I add them together, this particular pairing is what adds to a negative 1, which is what I was looking for. This one would add to a positive 1, so that's not the correct one. So as soon as you identify those numbers, remember this you get to do the AC shortcut on because A was a 1. And so look at all that time you just saved by factoring out the GCF. You now get to do the shortcut method, which means we just get to write this product of my two binomials. I have a W, so W gets put at the beginning of both of those. And these are my two numbers, a plus 3 and a minus 4. So plus 3 and minus 4. And you're done. Now, the student that failed to see that and went about it this way, you will eventually get to the correct answer, but you just cause yourself a lot of unnecessary extra work. So remember, when you're factoring descending order GCF, always do that first, and in the long run, it does save you time. Okay, so one final one. Again, this is a trinomial, but notice it's not of our standard form of the ax squared plus bx plus c, where this is just a number. So when you look at this initially, don't miss that. Again, if you get in the habit of always doing descending order GCF, you won't make these mistakes. So this is descending order. I have a cube, the square, and then this is x to the first. So it's descending order, but I can pull out a GCF. I mean, I can pull an x out of this entire expression because each of these has an x in it. So let me factor that x out first, and then let's write what's left behind. When I factor the x out of the cube, I'm left with an x squared. I'm left with 6x in the middle, and I'm left with a 5. So now, this is actually the trinomial, which does follow my ax squared plus bx plus c. This follows that pattern, and I will go use the AC method to factor this, and then this x is going to be hanging out front. If you do the AC method on this, again, if you realize that a is a 1, a times c is 5, that's a 5, my b is a 6, and again, hopefully pretty quickly you realize that 1 times 5 is a positive 5, and 1 plus 5 is 6. So that allows you to factor this pretty quickly, x and x, and then there's my two numbers, and because it was a shortcut, I get to just map them in instead of doing it the long way. And then don't forget the x's out there. So just be cautious, and again, if you can get yourself regimented into always thinking about following these steps, descending order, GCF, then let's go deal with what's left. That will be the most efficient, effective way for you to become proficient at factoring. The last thing I want to mention is there are some special types of trinomials called perfect square trinomials, and I'm going to have the next video show you how to factor a perfect square trinomial. The bottom line is this, is if you have a trinomial and you do not notice that it happens to be a perfect square trinomial, that is fine. You can factor it the traditional way. But something like this is going to be a perfect square trinomial. It fits a certain pattern, and the next video will teach you how to recognize if a trinomial happens to be a perfect square trinomial, because if you happen to notice it, there's a formula that you can just map this into, and it makes the problem very quick and efficient, even more quick than doing this one with an AC shortcut. So again, if you have trinomials and they happen to be perfect square trinomials, if you get good at identifying that, you can factor them really fast. But if you don't notice it, don't worry about it. The factoring methods I just went through will get you to the same place. It will get you to the same answer. And what a perfect square trinomial, what that means is when you factor, when you get the answer, those two binomials match, they're identical. And so sometimes you'll see somebody write it like this. Actually, they'll take that same factor and just say it's the factor squared. So this is by definition what a perfect square trinomial is, and I'll have a video on that. The last piece is if you feel very overwhelmed and you're like, oh my goodness, there was a lot going on there, you get the glare off that tray too. I would encourage you to watch the video again. But I also have this handout that kind of goes through and explains everything that we went through, and then goes through an example. And if you're interested in locating this handout, I'll show you how to get that. You can print it off if you want. And then this is the first page. The second page has some more examples, and they give you the examples and then practice problems, if you will, and then some answers. So how would you find that? If you just go out to your search engine, if you go out to the main MCC website, which is mcckc.edu. So if you just pull up the main Metropolitan Community College website on your computer, you should see this screen. Click on the tab called Current Students. When you do that, it brings up a whole menu. I'm going to scroll down so I can get to where I want to go. This one in the lower right hand corner, that's called Tutoring. So click on that Tutoring tab, and then what that does is it brings up each of the campuses within the MCC community, with the Blue River campus. So if you click on Blue River and then go to Math Lab, it pulls up a whole bunch of resources, handouts, So I did that really quickly, but again, so go to the math lab and it brings up all this stuff, and they're organized by topic. So there's a bunch of algebra handouts, and this is a college algebra class, so it is algebra. So we do have some college algebra handouts here, but a lot of them are also broken down by topics further. So there's an entire section called factoring. You can see calculus and trig, move past that. Equations and inequalities, you guys will be doing some of this later in the semester. There's some great handouts here. Exponents and logarithms, oh, great stuff. If I keep going down to factoring, this one right here is called Factoring the Traditional AC Method with Grouping, which is what we just did. So if you click on that link, it brings up that sheet that I just showed you. And again, it just goes through a description of the process. It goes through another example. And then finally on the back, it has a bunch of other practice problems if you're interested. So it gives you plenty of opportunity, and it will tell you what the correct answer is, so you can check your work if you need to. So again, if you're somebody that feels like this was a lot, a little bit overwhelmed, the key is that you need to practice. The more problems you practice factoring, the more efficient you will get at it, and hopefully these tools that I have shown you will help you feel more comfortable and get you well on the road to becoming an effective factorer.